Hello and welcome to another video lesson with Mr. Roman. Today we're going to be solving systems of equations using elimination. And so just a reminder here on the definition of what a system of equations is. And we would say that the solution to a system of equations is any ordered pair that makes all of the equations true. Another way you could say that is any ordered pair that satisfies all the equations in the system is a solution. So now let's look at an ordered pair to see if it's actually going to be a solution to this system of equations. So we have 3x plus 2y equals 20, 4x plus 6y equals 30. And we're going to test this ordered pair 2, 7. So first we're going to substitute the x in for x and the y in for y. And then we're going to evaluate that expression. So 6 plus 14 is equal to 20. And we get the statement 20 equals 20, which is true. So we've passed the first one. Now let's look at doing the same thing for the second. So we're going to substitute 2 in for x and 7 in for y. And then we're going to evaluate that expression, 12 plus 42. And that's 54 equals 30, which is a false statement. And that would tell us that the ordered pair 2, 7 is not a solution to this system of equations. Now, let's say we tested a different solution. Let's say we tested 6, 1. So we're going to plug in the x and the y there. And we're going to evaluate that expression. And again, we get 20 equals 20, which is a true statement. So we passed the first one. Now let's look at the second. Substituting in 6, 1. We're going to evaluate the expression. 24 plus 6 is 30 equals 30. That is a true statement. So now we've passed both equations. That would mean the ordered pair 6, 1 is a solution to the system of equations. Now recall that there are 3 possible solution types for a system of equations. So the first type is one solution. Algebraically, that's where one ordered pair satisfies all the equations. That's what we just looked at with the ordered pair 6, 1. So remember that would be this first type. Graphically, that looks like one point that all the lines on the graph share, or in other words, where they all intersect. Now, the second type of solution is infinite solutions. Algebraically, that's when all of the variables are eliminated and the remaining statement is true. Graphically, that's where the lines on the graph are all the same. So we're going to look at an example of that here just a little bit. And then the third type of solution is no solution. So algebraically, that's when all the variables are eliminated and the remaining statement is false. Graphically, that's where the lines are parallel, which means they will never intersect because they have the same slope. So to solve this system of equations using elimination, we're just going to use the concept of adding the two equations together. So I just put a little adding bar here, and we're just going to simply add straight down with the y's and with the x's. So if I add the y's together, I get 8y. And if I add the x's together, I get 0. And then if I add the constants together, I get -4 plus -36, which is -40. So check this out. That x variable was eliminated. So we're left with the statement 8y equals 40. I'm sorry, -40. Then to solve this for y, we simply divide by 8 on both sides, and that tells us y is equal to -5. So we've got half a solution here just with what we've done thus far. Now we can take that y equals -5 and we can substitute it in to the original equation either at the top or the bottom. In this case, we're just going to use the top one, the 2y minus 6x equals -4. So here I'm showing that substitution for -5. Then that's going to be 2 times -5, which is -10. Now to solve this part of the equation here for x, we're going to go ahead and add 10 to both sides. And then we're going to have -6x equals 6. And then we're going to divide by -6 on both sides, leaving us with x equals -1. So we would say then the solution to this system of equations is one ordered pair, which is -1, -5. And that's our type 1 solution. Okay, let's look at a second example here where we have the x's on different parts here and the y's on different parts. Well, we can just rearrange this top equation so that the x's and the y's line up. So let's first look at that. Line up the variables, switching around the 3y and the negative 2x so that it lines up with the bottom equation where the y's are vertically stacked and the x's are vertically stacked, okay? But now you can notice that if I used to add these two equations together, they wouldn't eliminate the y's and they wouldn't eliminate the x's. The idea here with elimination is I want to eliminate one of the variables when I add the two equations together. So what I'm going to have to do is look to multiply one of the equations by a constant so that it can give me a opposite coefficient for the x or the y. So we're actually going to try to eliminate the x's in this case. So looking to eliminate the x's, I want to turn this -2 into a -4. And we're going to do that by multiplying this top equation by 2. So we're going to show that here in blue. And when I do that, I get the equation 6y minus 4x equals 12. Notice I multiplied every single term inside the parentheses by that 2. Okay. Now I can just bring the red equation over and stack it underneath of the blue equation. And when I do that, you'll notice that here the -4x and the +4x, those are going to eliminate. But something else strange happens here. The 6y and the -6y also eliminate. That's odd, very odd. In fact, this is actually a special case. So notice also that the 12 and the -12 are going to eliminate. So when I go to add these two equations together, I'm going to get 0 on the left side, and then I'm going to get 0 on the right side because everything has been eliminated. Well, notice this is a true statement. 0 does equal 0. And what that means special case-wise is that we have type 2 solution, which is infinite number of solutions. So remember, algebraically, when all the variables are eliminated, the remaining statement is true. That's what we just looked at here with the this solution here. Okay, so now let's look at a third example. So here we have a third example. And again, we notice that the x's and the y's aren't lined up. And they're not even on the same side of the equation even. So what we have to do is we have to get all the variables on one side of the equations to start with. And to do that, we're just going to go ahead and add the 2x over. And then that's going to give me 2y plus x equals -6. And now I can just stack these two equations up next to each other. And whenever you do that, just make sure that all the variables are lined up. So in other words, the y's are stacked vertically and the x's are stacked vertically. Okay. And then from here, we're going to look to, we obviously know that if we add these two equations together, we're not going to eliminate either the x's or the y's. So we're going to have to multiply one of them. And I'm just going to go ahead and try and eliminate the x's here because I think it would be probably the easier version. And to do that, I'm going to multiply this bottom equation by a -3. Okay. And now if I do that, it's going to be multiplying a -3 times the 2y times the +1x and times the -6. That's going to give me this equation, -6y minus 3x equals 18. So again, notice I multiplied all three terms by that -3. And then we're just going to stack the red equation on top. And again, make sure your x's and your y's are lined up vertically. So now when I go to add these two equations together, you're going to notice again that this is going to be 0, this will be 0, and this will be 48. So let's take a look at that. 0 equals 48, which would definitely be a false statement. So this is actually another special case. This is the type 3 solution that we looked at earlier where there is no solution. So remember, type 3, which is here. Algebraically, when all the variables are eliminated, the remaining statement is false. That's where you have no solution. Okay? So let's go back to that. Type 3, no solution. Let's look at another example here, example 4. And again, you can see that There's variables on both sides of this equation, and they're not stacked up nice with this. So we're going to go ahead and get those all on one side. So get all the variables on one side of the equation. We're going to do that by subtracting 2x. And then that's going to be 6y minus 2x equals 48. So now we can just stack these two next to each other, which I've done here. And again, make sure vertically the y's line up and the x's line up. And so we've got all the variables lined up. And we're going to look to add straight down. But again, if I add straight down, none of the variables are going to eliminate. So I'm going to have to multiply one of these equations or possibly both. Because it looks like to here, if I were to multiply this 6 by something, I don't know what to multiply 6 by to get this to be a 5. Or even this negative 2 to multiply it to be 5. So I may have to multiply both equations. And what I'm showing here is I'm going to try and make the x's, in this case, into a 10, positive 10 on the top, and a negative 10 on the bottom. And to do that, I'm going to multiply the bottom equation by 5 and the top equation by 2. Okay? So on the top, if I multiply that 2 times 5y, the 2 times 5x, and the 2 times 0, I get 10y plus 10x equals 0. And on the bottom equation, if I multiply that 5 through, 5 times 6y equals 30y, 5 times negative 2x is negative 10x, and then 5 times 48 is 240. Now, I can simply add straight down, and notice my x's will eliminate in this case. And that's going to leave me with 10y plus 30y, which is 40y, and then 0 plus 240, which is equal to 240. Now I can divide by the 40 on both sides, and then y is going to be equal to 6. So I can use this in substituting to the top equation. And it doesn't have to be this top one. We could actually substitute this bottom one for y, but let's just go ahead and stick with the top one. So we're going to substitute that 6. 10 times 6 is going to be 60. And then we can solve this equation here for x by subtracting 60 from both sides. That's going to give me 10x equals negative 60. And then I can divide by 10. And then I can see that x is going to be equal to negative 6. So now I have an ordered pair. And this is type 1, where we have one solution, which is the ordered pair negative 6 comma 6, which is the solution to the system of equations. And that concludes our video lesson.